for anyone who knows anything about engines and cars, the idea of a piston is incredibly important because that is actually what is moving up and down, that drives the engine, that turns the wheels, that makes your car go, as well as a lot of other things in a lot of other fields besides automotives. But basically, a piston is a cylinder. Oh, such good art. Let's give it a little bit of a. Oh yeah, that's probably the best piston I've ever drawn. And so you've got this disc on top, which is connected to a crankshaft or something like that, usually to turn the engine. And you've got a gas down here in this portion, which is probably hot and trying to expand or something like that. Now, in our scenario, we're going to do something fairly simple because we want to keep it simple before we get big and talk about engines. Let's just say I have a cube, a mass, sitting on top of my piston. Not exactly cubic, but close enough. It's got perspective, we'll say. Awesome. Continues to be the best drawing I've ever done. And I just want to know, if you put this guy on here and you have a certain amount of gas in here, and we'll say its temperature is going to be fixed. So to hold temperature constant, you probably have to have everything change slowly. All right. So if you're holding the temperature constant and number of moles is constant too. Then how does your pressure and volume relate? So let's say you initially have a 1 liter or 0.001 meter cubed volume, and you have it at let's see. You have it at a pressure of, let's just say, sea level pressure, so 1 atmosphere, 101,300 pascals, or 1.013 kilopascals, or 1 atm, whatever you want to call it. And we'll say your temperature is fairly standard Earth temperature, 27 degrees Celsius, or 300 Kelvin. So this is all going to be your initial. So I'm going to put a 1 next to all of these. And then, yeah. So then you put a weight on top of it. You put this block on top because before it didn't have it. And you are going to see that your volume is going to decrease as the piston goes down, right? And temperature is held constant. So let's say your volume decreases by a factor of 2. So, and your temperature is held constant. So I know that T2 equals T1. So pressure 2, I want to know what pressure 2 is. So first, I guess let's ask ourselves a couple questions. Part A, how many moles of a gas do we have? And then part B, what is the new pressure? And then part C, I want to know what is the weight of the mass, or what is the mass. But to do that, I'm going to have to add a couple of things that we know. So I guess just the one, really. I have to add that the area of this cylinder on the piston, the movable part of the piston. So I'm going to say that is 0.01 meters squared. All right. So I think with that, we're ready to go. So if you want to solve this problem on your own, then you can pause the video here. And if you just want to see the solution, then keep watching because I'm going to do it. Okay, so part A is just going to be an exercise in using the ideal gas law. So we're just going to go ahead and write the ideal gas law. And we know our initial values for P, V, and T, and R is a constant, so we're just going to solve for N. So we know that this tells us that N equals P, V over RT, and we're just going to put in numbers. I'll pause it while I do the calculation so you don't have to watch. And that is going to be 0.041 moles. Okay, and that is part A. So we'll say N equals that for our notation. Okay, so then part B, I want to find what is the pressure to. Well, what I'm going to do is I'm going to take the version of the ideal gas law where I say that P1 V1 over T1 is equal to P2 V2 over T2. And I can do that just because I know that N and R are both constants. Actually, T is a constant, so I could have just said P1 V1 equals P2 V2. So I'm going to cancel those T's right away. So now I know that my volume went down by a half, right? So I know that P1 V1 over V2, I don't even need to know these values actually. I can just figure out the relative is equal to P2, right? So I can say then that since I know that V2 is half V1, those guys cancel, and I get that P2 equals 2 P1, or in this case, I know that P2 equals 202 600 pascals. And then finally, part C. What is the mass? So I know that what I want to do for this one, I want to figure out what is the force on my piston. So actually, maybe an interesting thing to do would be to also figure out what is the mass added and what is the mass of the cylinder itself. So let's add that. Let's just say part D. Let's put question marks on both of these to make Miss Stevens happy. So to do this, I'm probably going to need a new sheet of paper. 1 second. So I'm actually going to do part D first because I was originally going to do part D as kind of on the way. So maybe it's like part B and a half. Or part C1 is maybe a better thing to do. Let's just call it part C1. So this is going to be, what is the mass of the piston? So I know that the bottom area of the piston, right, has an area of 0.01 meters squared. And I know that initially, before I put the weight on it, I know that the pressure was 101,300 pascals. Yeah. So I can figure out what is the force that this would exert on that area, because pressure is force per area, right? So if I could just multiply both sides by A, so I can say A times pressure equals force. That's a force. There we go. So, and the upward force on that piston, right? This upward force will cancel its weight, because its weight is going to be a downward force. So I'm going to just plug in my numbers here. So it's 0.01 meters squared times 101,300 newtons per meter squared. And that's equal to force. So let me type it in my calculator. I'll get right back. So when I type these into my calculator, which I guess I didn't really need to do because I could just move the decimal twice, I would get a force of 1,013 newtons, which tells me, most importantly, that I picked too big of numbers for this problem, because I was kind of just picking them as I went along. Because it's unrealistic for a 100 kilogram piston. But those are the numbers we have, and this is real simple math, so I'm pretty sure we did it right. Let me know if I did it wrong, though. So part 2, we want to know what is the mass that we put on top of the piston, right? That's going to be C2. So I guess we should say that mass then would have to equal 101.3 kilograms up here. Okay. So what is the mass that is placed on top? We'll say MP here. So I know now that the force, if I draw my free body diagram, this force here has to equal the weight of this guy and the weight of the piston together, right? So if I do the same math, P times A, so I don't know what this force is yet, but I know my area hasn't changed, my pressure is doubled, which means that this is now 202,300 newtons per meter squared. This is 0.01 meters squared. So this is twice the original. So this is the new mass has to equal the old one too. So the mass that I've added is also going to equal 101.3 kilograms. Ooh, I went off the bottom there. There you go. So that's how we finish that problem. And I hope this was helpful to you guys. I'll see you in the next video.